Hello, good morning, students. Today's learning objective is objective number 7. Okay, objective number 7. Describe and explain the rapid transmission of an impulse in a myelinated neuron with reference to saltatory conduction. So, saltatory conduction, let me explain. It means jumped or hop, jumping or hopping. Yeah. Somehow yesterday, I've already explained this objective number 8. Yeah, this is already done yesterday. Explain the importance of the refractive period in determining the frequency of impulses. Yeah, remember there are two important there are two important points that you need to know about refractive period. The first one is to limit the number of impulse that can be produced per unit time, and number two is to ensure that the nerve impulse will only move in one particular direction. Okay, so conduction of nerve impulse or progress of an impulse. There are a few MCQs here which you can do in your own time. Yeah, you can have a go. Question number 45, 41, and question number 12. Okay, you can do that in your own time just to save time. So conduction of nerve impulses, progress of an impulse, or progress or propagation. So once an action potential has been generated at a particular segment or a particular section, how does it travel along an axon from one region to the next? Okay, so I'm talking about in non-myelinated as well as in myelinated. So the formation of action potential at a particular section of axon membrane involves temporal depolarization which set up local electrical circuit. Now this is important. This term here, I want you to get used to this term. Local electrical circuit is being set up. Yeah, local electrical circuit. In some textbook it's mentioned local circuits, yeah, or local electrical circuits. What does it mean, local electrical circuit? It means that positive ions are attracted to negative zone and flow from the positive region to the negative region. Or it says here positive ions are attracted to negative zone and flow from positive region to negative region, or positive region attracted to negative region, positive region attracted to negative regions. Okay, so it's very important to get the conception correct. Yeah, the positive ions are not attracted to the negative ions, because even though that may be correct, but the conception is that negative zone will be attracted, positive zone will be attracted to negative zone. Yeah, or active region or depolarized region or positive region attracted to negative region or resting region. Okay, if we look here, so this is with this particular diagram here, as you can see here, this is not myelinated, this is non-myelinated, yeah, myelinated neuron. Okay, I've already mentioned some, yeah, in our previous lectures. So this is the meaning of negative when an action potential occurs in this particular region here. Okay, so local electrical circuit is set up. So what is local electrical circuit? Local electrical circuit means positive region attracted to negative region. Okay, and likewise this one here, positive region attracted to negative region. Okay, so that's the meaning of local electrical circuit. So the polarized region will be attracted to resting region. okay, depolarized region will be attracted to resting region. Okay, we will look into that later on. Again, there are some terms that you need to know. So avoid using the term messages. Okay, do not use messages, but rather use nerve impulse. Or I think you can also use the term electrical impulse. Okay. So let's look at the conduction of nerve impulse in a non-myelinated neuron. So once you have understood in a non-myelinated neuron, in a myelinated neuron, it will be easier because there are two different types of conduction. One is in non-myelinated, and the other one is which is myelinated. Yeah, the myelinated is what we call the saltatory, conduction. Yeah, so saltatory conduction, as you can see here, is in myelinated, so saltatory. In non-myelinated, there is no saltatory, yeah, because in non-myelinated, it has to pass through all segments. It has to pass through all segments. It doesn't jump. Okay, it doesn't jump. Okay, most of the neurons in the human body are myelinated. However, some parts of the body contain non-myelinated, such as the relay neurons, okay, in the spinal cord. So it's not abnormal if our neurons are not myelinated, because our relay neurons are not myelinated, okay. Remember, in multiple sclerosis is a condition where the neurons are losing the myelin shield. Yeah, the neurons are losing the myelin shield, and therefore there is no the conduction of nerve impulse is not properly conducted. Okay, so that is a different case, because there are also neurons in our body which are naturally not myelinated, such as relay, yeah? Such as this relay neurons. Okay, now let's have a look here. First of all, the conduction action potential will always start at the when these dendrites receive nerve impulse from the previous, yeah, from the earlier, yeah, from the first neuron. So there will be incoming, there is a, for example, there's a motor neuron here. This is a motor neuron, yeah? This is a motor neuron because the cell body is at one end. So there should be another motor neuron here which connects to this motor neuron. So there is an incoming nerve impulse from here, and so it will be picked up by the dendrites. Okay, picked up by the dendrites. And so the action potential actually already starts in the cell body here. Yeah, they call it the axon helix. If you do the MCQ, you will understand what I mean by axon helix. So action potential already starts here, yeah, in this cell body. So it's positive here, okay, negative outside, and the rest will still be negative. Okay, like that. And this will continue to propagate. So propagate means moves along a particular it moves along this axon. Propagate, yeah, travel along this structure. So when there is an incoming nerve impulse here, the sodium channels will open, so there is an influx of sodium, okay, and so the inside becomes more positive than outside. Okay, and now this one will propagate along the axon. So when you see this particular diagram, it already starts in somewhere in the middle here, yeah, when actually it is supposed to begin at one end, yeah, at one end, like here, It's supposed to start from, you know, the dendrites and then the cell body, and then it should move along. Okay, so this particular textbook already shows that it's already somewhere along in the middle. Okay, bear in mind that it should start at the cell body. Okay, it should start it here, and then it will move along. Okay, so you can see here an actual potential occurs. So let us recap again. I've drawn some. You need to learn again. You need to recap again about the resting membrane. Yeah, how the resting membrane is maintained. Yeah, the resting membrane means the inside is negative compared to the outside. Negative means less positive ions, more positive ions on the outside, less positive ions on the inside. Yeah, resting membrane is about minus 40 millivolts. Okay, if we go back to here, okay, so why the inside is negative? That's because there is less sodium, yeah, and there's also less potassium. Okay, less sodium. Why less sodium? Because most of the sodium channels are closed. Yeah, remember when we talk about this, there's a high concentration of sodium outside and low concentration on the inside. But because most of the sodium channels are closed, the sodium cannot enter, and so there is less sodium. On the other hand, there is a high concentration of potassium on the inside, low concentration of potassium on the outside. But because the potassium channels are open, so potassium will leave the inside, so that's why the inside has less potassium. So this is the reason why it's negative inside. Yeah, the inside is negative because it has less. The inside is negative, outside is positive, because it has less sodium and less potassium. Yeah, why less sodium? Because the sodium channels are closed. Why less potassium? Because the potassium channels are open, so it will keep on leaving the inside of the cell. Okay, so that is a very, very important concept that you need to understand. Yeah, so I've written down here, as you can see here, less potassium, less sodium, and there's more potassium, more sodium. Okay, so when there is an incoming nerve impulse, okay, when there's an incoming nerve impulse here, so what happens is that action potential occurs. Yeah, so initially it occurs in this cell body. Cell body, there's another name here for cell body. Another name for cell body is soma. But Cambridge, British, UK syllabus, we use the term cell body. In the US, they also use the term soma. Okay, to make reference to the cell body. Another name is soma. So they're the same. So actually, initially, the area which will be positive is in this area here, positive. Okay, but let's just begin here. Okay, we begin here. So when the nerve impulse arrives at the dendrite, and it will pass on to the cell body region, and then to this area here, the axon helix. So this will become positive. Okay, this becomes positive, then the outside becomes negative. Why positive? Because now the sodium channels are open. So sodium will enter. This is a different color here. Sodium will enter. Yeah? And potassium cannot leave. Potassium cannot leave here because in an action potential, the sodium channels are open, so sodium will enter, and then the potassium channels are closed, so potassium cannot leave. So now the inside becomes more positive compared to the outside. Okay, so once the inside here becomes positive, okay, so I wrote down here, I put a cross here. It means cannot, yeah? Just put a cross. It means cannot, okay? Potassium cannot leave. So when the inside is positive, what happens now is what we call the term local electrical circuit. So let me write down. So now local electrical circuit is established or is set up. Yeah. What is the meaning of this local electrical circuit? It means that positive region will be attracted to negative region. Positive region attracted to negative region. Okay, positive region attracted to negative region. So the entry of sodium here and the prevention of the potassium from leaving the membrane causes the inside more positive. So this will influence the next segment. Yeah, this will influence the next segment, which means that the influx of sodium here will cause the influx of sodium in the next segment. Okay, and so this region now becomes positive. So this is the meaning of local electrical circuit. Yeah, this one becomes negative. This one also becomes negative. Okay. So the same story occurs, yeah, which means that the sodium will enter here, sodium will enter, and the potassium cannot leave. Potassium stays here, cannot leave. Okay. Now, the next point is very, very important. The previously active region. So this is the previously active region. This is now in refractory period. Okay, so this in refractory period means it's going to go back to the previous resting state. Yeah, so to the previous resting state is that what happens is that potassium channels begin to open. Now the reverse will occur. Potassium channels begin to open and sodium channels begin to close. Yeah, so potassium now can leave. Okay, potassium now can leave. Okay, potassium can now can leave, and then the sodium channels are closed, so sodium can no longer enter. So it goes back to. So now this one will go back to its previous state. Goes back to negative. Yeah, and this one becomes positive. Okay, so this is still refractory period. Okay, this is still in refractory period. Okay, refractive period. Refractive period means if there is an incoming nerve impulse, another incoming nerve impulse, this area here cannot be stimulated because the sodium channels cannot be open. It's still closed. So that means it will only limit one particular impulse. So once this impulse has gone, then only then can another impulse occur in this same neuron. Okay, and the refractive period also ensures that the nerve impulse travel only in this direction. Yeah, only in this direction. If I can use a bigger, the nerve impulse only travel in that direction. Yeah, because this is positive, this is negative. Yeah, positive region attracted to negative region. That means positive region can also be attracted to this region here, but it will not be attracted to this region here because this is still in refractory period. So there's only one way for the action potential there's only one direction, and that is in this particular direction to the left hand side. Okay, so again, so this thing will continue again. Yeah, so this positive here, this positive region will be attracted to the negative region. So this is called the local electrical circuit, meaning the influx of sodium here causes this area here to become positive, which triggers or influences the entry of sodium in the next resting region. This is the next resting one. Yeah, and so this will later become positive, and so this will happen along the neuron. Okay, and this is what you see here. Okay, what you see here, positive region attracted to negative region, positive region attracted to negative region. But this part here, how this one becomes negative, you have to understand as well that this becomes negative. I mean, later on, you see the arrow here, that means later on this one will become positive and this one becomes negative. Okay, and this one becomes positive, positive, negative, negative. Yeah, so you have to know why it becomes positive on the outside. That's because sodium, the sodium cannot enter. Sodium cannot enter, but the potassium begins to leave. Okay, sodium cannot enter, but then the potassium begins to leave, and so the inside becomes negative. And so that's why, because there's more positive ion on the outside. Okay, so you have to still know how, why, how does from some previously positive, how does from previously positive becomes negative. The importance here is the reason. Okay, this is positive. How from positive it becomes negative, and then outside becomes positive. So you still have to know the reason in terms of the movement of ions. And you see there, local electrical circuit. Okay, basically the local electrical circuit means positive region attracted to negative region. Okay, that's the meaning of it. This is taken from old textbook. They use the term local electrical circuit as well. See, local electrical circuit. Okay, you see the entry of, this is a very good diagram here. The entry of sodium, it's different color here. The entry of sodium here, okay, causes the entry of sodium in the next segment. Okay, so this one later on will become this area here later on will become positive, negative, negative, because of the entry of sodium, and that causes the entry of sodium in the next segment. Okay, so that's the meaning of local electrical circuit. Okay, So in terms of words, it's all written down here. Okay. So if you the terms that you need to use, this is also very, very important. The terms you have to, for example, if the action potential, so like this part here, in this region here, this is okay. This part here, this is active region, or also known as depolarized region. And then this part here, if I can use a different color, this is called, this part here, this is resting, yeah, resting region. Okay, so local electrical circuit means positive region or active region. Let me just put another one here, positive region or active region or depolarized region will be attracted to the resting region. Okay, will be attracted to the resting region. It will not be attracted to this part here because this is still in refractory period. Yeah, this is in the refractory period, so it is only one way it goes in this particular direction. So that's the meaning of local electrical circuit. Okay, you can also read here. Okay, now in a myelinated neuron, it's now very, very easy because in a myelinated neuron, because of the myelin shield, the presence of this myelin shield, which acts as electrical insulator. Electrical insulator means, what is the meaning of electrical insulator? This area here, this part here, sodium cannot enter. Yeah, sodium will not be able to enter. Cannot enter. And not only sodium, but potassium cannot leave. Potassium also cannot leave at the same time. So this is the meaning of myelin shield as electrical insulator. So the only areas that sodium can enter is in this region here. This is the only area where sodium can enter and potassium can leave. This one as well, this one as well, and this one as well. And so the way it moves is that it will skip. Yeah. So the way it moves is that it will jump. It's not actually jumping. Yeah. It's not actually literally jumping, but it's actually, it skips this area here. Skips this area. Skip this area, meaning it doesn't have to go through. It doesn't have to go through this section here. So it will just, the local electrical circuit will just be attracted to this, attracted to this, attracted to this, attracted to this, and that's why it will be faster. Okay, it will be faster. So myelin shield acts as an electrical insulator to the axon membrane. Action potential cannot form where myelin is present because sodium cannot diffuse into, and not only sodium but even potassium cannot escape as well, cannot leave. Okay, so this is a very important statement. Okay, sodium cannot diffuse into as well as potassium cannot leave. However, action potential can form at the nodes of Ranvier, where the myelin shield is absent. The nerve impulse therefore jumps or leaps from node to node. So bear in mind the term jumping or leaps, it doesn't literally mean that it jumps. Yeah, it just simply means that it skips. It skips this area here. Yeah, it skips this area. It will not have to go to this area. It will not have to go to this area. It will not have to go through this area. So it just simply jump. The node behind is not stimulated because it is still in refractive period. So the same thing, the same concept occurs. So as you can see here, it jumps. Okay, it jumps from here to here. So if this is active, this is resting, so this one goes here, this one will be in refractive period. This is active, this is resting, it jumps again, this one will be in refractive period, and this is become active again. Okay, so saltatory conduction occurs in myelinated neurons. The nerve impulse jump from one node from one node of Ramvier to the next. Because action potential are prevented by the myelin shield, they can only occur at nodes. The nodes of Ramvier are gaps in the myelin shield which occur at intervals along the axon. So the effect of myelination is to speed up the nervous conduction. So it makes it faster. Okay, makes it faster. So here, as you can see here, okay, so the same thing, they're going to use the term local electrical circuit. Okay, what is the meaning of local electrical circuit? Positive zone attracted to negative zone, positive zone attracted to negative zone, and so on and so on. But you have to know in terms of the movement of ions, because the entry of sodium here will influence the entry of sodium in the next segment, and then in the next segment, and in the next segment. Okay. So in terms of the graph, this is a good slide here. Yeah. So if there's an action potential here, so there will be a graph here, and then there will be another graph here, and this graph here will be gone, and then another graph here, and this part will be gone, and then and so on and so on and so on. Yeah. So it's like this. There is only one impulse. The impulse starts from here, and eventually the impulse will reach the end of the at the end of the neuron here. Yeah, so it's like, you know, if you see it's like the movement of the beating of the heart lah. Yeah. All right. And this is from the same, from different textbook. Okay, but basically talks about the same thing. Okay. All right. As you can see, this is taken from another textbook, the Saltatory Conduction. Okay. Okay, as you can see this again. Okay, from different textbook. Okay, as you can see here, this is positive. I'm trying to understand this part of the graph here, the picture here, the image here. So this is positive here. So positive, this is the active region. So local electrical circuit means it will be attracted to the negative region here. Okay, as you can see, plus here meaning sodium enters. Okay, and then it will cause the entry of sodium in the next segment. Okay, in the next segment here, and then this will become refractory period. Okay, and you can see the potassium now begin to leave because this is about to become negative. Okay, this is about to become negative. So so this is the meaning of the localized circuit. Yeah, localized circuit means positive region attracted to negative region, positive attracted to negative region. Okay. It's taken again from, as you can see, the more sodium here, plus means more sodium will cause sodium to enter in the next segment. So sodium will enter here. Okay, sodium will enter here. Okay, and then the refractive period. So we have mentioned this refractive period yesterday. Yeah? So it has two important, just a recap, two important points, and that is to limit the frequency of nerve impulse, okay, or to limit the number of nerve impulse that can pass along an axon in a given time, which is to conserve energy, and only ensures that nerve impulse pass in one direction along an axon. I did mention that there are two types of refractive period, which is not really important. It's not even mentioned in the syllabus. So it only mentions refractive period. It doesn't say absolute. It doesn't mention about absolute and relative. Yeah, absolute and relative. It says here refractive period. So it's not really important. But the thing is, what's the difference between absolute and refractive period? So this is absolute, and this is the difference between absolute and relative. Yeah, absolute means after action potential occurs about 2 millisecond, at about 2 millisecond here, no action potential can occur in the next one, no matter how strong the stimulus is. Yeah, no matter how strong the stimulus is. But in the relative refractive period, it means after at about 3 millisecond here, action potential can occur, but the stimulus must be higher than the previous one. That's the meaning of relative refractive period. Okay, so I repeat, absolute, it means that after action potential occurs here, no action potential can occur in this part of the time, yeah, no matter how strong the stimulus is. But in the after about 3 millisecond, okay, according to this time here, action potential can occur, but the stimulus must be stronger than the previous one. That's the meaning of relative refractory period. Okay, let's just finish this up, yeah, so that I know it will take, I think it's taken about almost an hour now. Let's just finish off all of the the notes here. Features or characteristics of nerve impulse: the all or nothing response. The impulse is non-decremental. The larger the stimulus, the more impulses, not frequency, not amount, fired off per second. These are very important, very important characteristics here of nerve impulse. The first one is the all or nothing response. Yeah, the all or nothing response means is either you get an action potential or you don't get at all. Yeah, meaning the stimulus must reach a certain strength or threshold. The threshold is about minus 55 millivolts. Yeah, minus 55 millivolt. This is the strength of the threshold. The threshold value is about minus 55 millivolt. Meaning, if the stimulus doesn't reach this amount, then there will be no action potential. Yeah. But if the stimulus is higher than minus 55 millivolt, then you get an action potential. And if you get a stronger stimulus, you will get the same amount of action potential, meaning plus 40 millivolt. Yeah. So for example, let's say you have a medium size stimulus. You will get plus 40 millivolt. If you have a strong size stimulus, you will also get plus 40 millivolt. Yeah, provided that the stimulus must reach threshold. Okay, the threshold is about minus 55 millivolt. Okay, so the response is still the same, 40 millivolt. Okay, the only difference will be what differentiates strong stimulus and weak stimulus is the number of impulse per unit time. So for example, if I can draw, so you might get something like this, okay, like 3 waves per unit time. For example, this is a weak stimulus, but with a strong stimulus you get maybe about 4 waves. Yeah, strong stimulus. Okay, but the value of the action potential, the value of it is still plus 40 millivolt. Plus 40 millivolt. What differentiates a strong stimulus with a weak stimulus is the number of impulse per unit time. Okay, this will get less nerve impulse, this get more nerve impulse per unit time. Okay, so the importance of threshold is very, very important. Yeah, the threshold is about minus 55 millivolt. This is threshold, and this is very, very important because you do not want, why this threshold very important, because you do not want your body to respond even to very, very low stimulus. Yeah, you do not want to respond to unnecessary stimuli, unnecessary low stimuli. Okay, and this is the importance of threshold, because some creatures like dogs, they are able to listen, they're able to respond even to very minute sound, very, very small sound. Yeah, they're able to respond to that because the threshold is very, very low. But for human beings, we don't want to, we do not want to listen to this very, very small or very, very tiny noise. Yeah, because we want a peace of mind. We want, we want to, for example, we want to, have less disturbance. Okay, and so human beings have this very high threshold, about minus 55 millivolts. Another good example is if your skin, your hand, yeah, your hand, and if there is an ants, yeah, sometimes you don't realize when these ants, when they crawl on the surface of your skin, yeah, you don't realize that actually there are ants which crawl on your skin. You're not aware of it. That's because of when the legs of the ants press against the receptor, the pressure receptor on your skin, it doesn't reach the threshold value. Yeah, and that's why you are unable to sense their presence. Yeah, but a slightly bigger ant with a slightly heavier weight or mass, because it put enough pressure on your pressure receptor to reach the threshold value, only then can you sense its presence. Okay, so you do not want, that's the reason of this threshold value. Is very, very important for human beings to have this threshold value. Okay, so the threshold and the all or nothing response, meaning when you get the extra potential, the value of the extra potential will be the same, which is plus 40 volt, not higher than that. Yeah. The size of the impulse is independent of the intensity of the stimulus. So a more intense stimulus will not give a greater action potential. But an intense stimulus will only give you more higher frequency. An intense stimulus will give you higher higher frequency. Okay, like this one here. Weak stimulus, nothing happens here. Slightly higher, nothing happens here. Strong stimulus, there is an action potential. Very strong stimulus, there's an action potential. The action potential, the value of the action potential is the same, yeah, plus 40 millivolts, plus 40 millivolts. The only difference between the two here is the frequency. Frequency. A stronger stimulus will have more frequency per unit time. Okay, this is a very good example of that, yeah. Weak stimulus, nothing happens here. Just above threshold, you see one action potential, and then this one will move. Stronger stimulus, you have like that. You have this straight away a burst of action potential per unit time. Yeah, meaning faster. This one will be just like that, whereas this one here, like that. Stronger stimulus. Yeah. And this is the difference between softer voice and louder voice. For example, someone might sit at the back of a classroom. At the back of a classroom. For example, this is a teacher is standing here. Okay, teacher. And then a student is here. If the student whisper, okay, whisper mean in the sense that whispering, but the teacher can still manage to, just barely enough, yeah? Just barely can listen. Okay? If the student at the back here whisper and the teacher barely can listen, so that's meaning it's like this. The wave is like this per unit time. But if the student shouts, so instead of whisper, now the student shouts, okay, then the teacher will be able to register that faster. Okay, so in terms of what happens in the action potential in the ears, yeah, of the teacher, so it will be like this. It will be faster. So I hope that's clear, yeah. Okay. All right. The impulse is non-incremental. That means non-incremental means it will stay at plus 40 millivolt, meaning this one here will still be plus 40 millivolt until the end, plus 40 millivolt. It doesn't decrease in value. That's the meaning of non-decremental. The larger the stimulus, the more impulses, meaning frequency, yeah, not amount or size, are fired off per second. However, consecutive impulses will only take place after the refractory period. So these are like this. Okay, impulse. Weak stimulus like this, slightly strong, it will be like this, stronger will be like this. Okay. All right, and then the speed of the conduction. If those of you take physics, yeah, you will know this. The diameter of the axon. The greater the diameter, the less there will be less resistance. Yeah. So the thicker axon will transmit the nerve impulse faster. Okay. And of course, myelin shield. Those axons which are myelinated will transmit the impulse faster. So already mentioned here the diameter, the myelin shield. Temperature is to do with the kinetic energy. Yeah. Kinetic energy of what? We're not talking about substrate or enzymes. The kinetic of the ions. Okay. Kinetic energy of the ions. Kinetic energy of the ions. And then the concentration of the sodium, the greater the difference in concentration gradient, of course, the more faster will be the transmission. And this is a very interesting fact here. This is very, very interesting. If you read here, because of illness, so when you are illness, when you become ill, or when you are sick, yeah, people tend to have reduced concentration of sodium ions, and reduced concentration of sodium ions will affect the conduction of nerve impulse, and that's why when you are sick, your movement is very slow, you're very weak, yeah, because action potential formation is very slow as well. Okay. This is the to do with the diameter. So the larger the diameter, the faster will be the conduction. Yeah. Okay. So I think that's all for today. So tomorrow we're going to talk about, sorry, Saturday we're going to look at synaptic transmission. Yeah. I hope this really helps you to understand today's material. So Saturday, I'll see you again on Saturday on synaptic transmission. So we have actually covered all of this already. Yeah, 1 2 3 4 5 6 7 8. So on Saturday we're gonna look at synaptic transmission. This will be on Saturday. Okay, that's all for the day.